Hi everyone. We are going to be learning about how to integrate using partial fractions, how to decompose a given rational expression like this into partial linear fractions. Let's begin with how to know to use this method. So we have a rational expression that we're trying to integrate here, and the denominator looks like a quadratic. It's bottom heavy. So the first question I would ask myself is the denominator factorable? So we'll pause the integration here, as after we decompose it into partial fractions, we'll be integrating it. We'll go ahead and decompose this into partial fractions. And we'll begin with factoring this denominator. So let's copy our rational expression to the side. There are many ways to factor a quadratic expression. As long as you factor it correctly, it doesn't matter what method do you use from Algebra 1. So this will factor in the end as x minus 2 times x minus 1. So after doing that, we'll move to the right side and we'll say an unknown over one of the linear factors plus another unknown over x minus 1. Imagine this as we are having 1 over 6 and had a 6 factor, 2 times 3, and then later figuring it out that this is 1 over 2 minus 1 over 3. So just like that, taking it and breaking it down to summation or subtraction of simpler fractions. So that's the goal. All right, let's continue. Now we'll quickly get common denominator here. So we'll need to multiply the right side with, as you know, x minus 1, and the top as well. And the right side will be multiplied with x minus 2. Okay, so on the left side, we have 1 over x squared minus 3x plus 2. And on the left side, we have a times x minus 1 plus b times x minus 2 all over the common denominator. Okay, so now let's take a look at what we have. We have single fraction on the right side, single fraction on the left side, and denominators are the same. So numerators must be same as well. Let's talk about this a little bit on the side. So if I say a over 5 is equal to b over 5, wouldn't you think numerators must equal as well? So for that reason, we'll go ahead and say, we'll ignore the denominators at this moment, and we'll say, well, numerator must equal to the numerator. And at this point, we'll make smart choices for the x values, and those smart choices would be what makes this parentheses, this factor equal to 0. Set x is equal to 1. 1 will equal to, the reason we chose that is this will be completely 0 when you substitute 1 for x. And so 1 will equal to b times negative 1, and this will result in b being negative 1. If you set x is equal to 2, 1 will equal to a times, what's 2 minus 1 here, which is 1, and this will result in a being 1. So now we were hoping to find a and b, now we did. Now we'll just go back and put it back. So 1 over x squared minus 3x and plus 2 will equal to a, which is 1 over x minus 2, plus b, which is negative 1 over x minus 1. So we took this rational expression with the quadratic denominator and we decomposed it into simpler fractions. We don't know how to integrate this, but we know how to integrate these. So this will come in very handy. So I will go ahead here and now I will replace this expression. Now I'll go ahead here and I will replace this expression with these two simpler fractions. All right, let's integrate the first one. Integral of the first piece plus, I will kick negative 1 multiplying constant to the front, integral of the second piece, which is, here you go. We've talked about this before. We don't need a u sub here. If we call this u, this will be du. So this is one of those cases where we could bypass the u sub. So the answer for this integral will be ln of x minus 2 in absolute value and minus 1 times ln of x minus 1. And for both of them, 1 plus c at the end. And as you know, ln of a minus ln of b, we can condense this to a single logarithm. So our final response will be ln of x minus 2 over x minus 1 plus c at the end, and we're done with integration. So the moment we take this rational expression and decompose it into partial fraction, integration becomes super simple. I know it looks like decomposing into partial fractions may take some time, but this will be like something you can do under a minute once you practice how to decompose into partial fractions. Hope this makes sense. Now it's your turn to try a problem. You may attempt this question. Please pause so that you could solve this on your own, then watch the solutions for this one as well. All right, welcome back. I hope you solved the problem. So we'll copy our rational expression to the right side like we did the last time, and we'll go ahead and decompose this into partial fractions. So this is a factorable quadratic expression, and that's our clue that this may be actually true partial linear fractions. So I'm going to give it a try to see if I can decompose this into linear fractions. So I will say a over the first factor, linear factor, plus b over the second one. We'll go ahead and get common denominator. Okay. So now we'll ignore the denominators because denominators are all the same. So numerator plus numerator is equal to the numerator, as we talked about in the last problem. So 1 is equal to a times x minus 1 plus b times x plus 2. And to continue solving for the unknowns, we'll make smart choices for the x values. So we'll say set x is equal to 1. This will be going away. When you plug in 1, this will be 0. So 1 is equal to b times 1 plus 2, which is 3. So this will result in b being 1/3. Set x is equal to -2. 1 is equal to a times -3. And this will give us a as -1/3. Okay, so now we know A and B and we can put them back. So when I am putting this back, I want you to think of A over x plus 2 as A times 1 over x plus 2. So it's okay if I put negative 1/3 in the front times 1 over x plus 2. So the A in the numerator can be imagined in the front, right? And then so that A happens to be a fraction. Hope this makes sense. So now let's go ahead and replace this with what we have. So A is equal to, I actually will choose to put the multiplying constant in the front. A is in front, A times 1 over x plus 2. So I can kick A in front of the, A is a fraction, A times 1 over x plus 2. So I can kick A in front of the integral. So this will be negative 1/3 times dx over x plus 2. And then B times, what is B? Positive 1/3 times dx over x minus 1. Okay, let's check if we placed it correctly. A is negative 1/3, yes, and B is positive 1/3. Okay, so they were multiplying constants, like A times 1 over x plus 2, and B times 1 over x minus 2, x minus 1. And so it's okay if I put it in front of the integral, right? So this will be negative 1/3 ln of the bottom, because x has a coefficient of 1. If I call this u, this will just be du, so it will end up being ln of x plus 2. And then this will be 1/3 ln of x minus 1 and plus c. Okay? Now, how can we condense this? So I'm going to factor out the 1/3 from the first two, and I will choose to write ln of x minus 1 first, because that's the one with a positive coefficient in front. And then I will write x plus 2, ln of x plus 2 later, and plus c at the end. So this will be 1/3 ln, condense it, as you know, and we did it in the last problem as well. So this will be x minus 1 over x plus 2 and plus c. So this could be in the choices. So this could be in the choices. This could be in the choices if it's a multiple choice question. Or a third thing that we could do is we can take this 1/3 and put it as a power to the entire expression in the inside. So I can also say this is ln of this whole thing to the power of 1/3, which is cube root, right? So this could have been cube root of that entire expression. So x minus 1 over x plus 2 plus c. All right. Hope this makes sense. Thank you for listening.